Hey everyone, GraphDBA here with another video, and this is part 2 of creating copies of Oracle ASM disk groups using SnapVX, the snapshot technology of a Dell PowerMax. In this video, I am going to demonstrate refreshing a snapshot with the latest copy of the source data, and then also terminating the snapshot and completely getting rid of it. But first, the boring legal stuff. Yeah, standard disclaimer stuff, your mileage may vary, void where prohibitive, etc., etc. The salient point is, I work for Dell Technologies, and that said, my opinions are my own and do not necessarily represent Dell. Good? Okay, let's move on. So in part 1 of this video, I showed how to make copies of 2 ASM disk groups for a swing bench database. The disk groups were swing data with the data files and swing redo for the redo logs. I made a snapshot using SnapVX, and then I used Unisphere to create linked devices and a target storage group. I then linked those devices in the target storage group to the snapshot that I had created, and I provisioned the result to a pair of database hosts running Oracle 19C RAC. I then relabeled the disks using the ASM filter driver. I renamed the ASM disk groups to Snap Data and Snap Redo respectively, and I mounted the disk groups. Now we are going to refresh our ASM disk group clones, bringing the latest copy of our database to the clone environment. This is the sort of operation you might need to do to refresh a development environment with the latest copy of production data. Or you might need to refresh a QA environment so that you can test the latest patch set against an exact clone of production to know if your patch will cause any unexpected problems when you do apply it to production. You might ask why we don't simply delete the existing snapshot, delete the target storage group, and delete the linked devices. We could certainly do that. But here's the thing. When we created those linked devices, PowerMax assigned those volumes unique WWN identifiers. And when we rescanned the SCSI bus, our mount host saw those WWNs, realized that they were new devices, and mapped them in as SCSI devices, which PowerPath then assumed management of. If we now delete them and create new ones, we would have another completely new set of WWNs. We would have to rescan the SCSI bus again, which can take a little time depending on the number of devices and paths to each of those devices. PowerPath would also have to assign new aliases for the new devices. Not only does this take time, if we are in a virtualized environment, it can be exceedingly tedious to map and unmap RDMs to and from a VM. So instead, we are going to take a fresh snapshot and then link our existing link devices to that new snapshot. As far as the OS is concerned, nothing happened. No devices were removed, no new devices were discovered. Similarly, PowerPath sees no changes. All devices are still present and accounted for. All devices retain their existing aliases. But as far as ASM is concerned, the contents of those disks suddenly changes. Our renamed disks and disk groups are gone. The devices suddenly reflect the current state of the source system, so we will have to rename our disks and disk groups again. Let's explore this. I'm back in the Unisphere interface, and if I select the swing data storage group, I can show you that we still have the first snapshot taken at 16:07:44, and the snapshot is linked. I am now going to create a new snapshot of the same swing data storage group using SnapVX. When I go to make the snapshot, Unisphere asks me if I want to use a new snapshot name or an existing one. If I select the existing snapshot, Swing Data Snap 1, the PowerMax would create a new snapshot of my storage group using the same name as before, but with a new timestamp. I would then have 2 snapshots called Swing Data Snap 1, each one with a different timestamp. While this might at first sound confusing, consider if I scheduled a recurring snapshot on, let's say, a Friday night at 9 p.m. I could then call my snapshot, for example, Friday_9 p.m., and the PowerMax would happily maintain a library of such snapshots, each with a different date timestamp. In this scenario, however, I'm going to use a new snapshot name, called very creatively, Swing Data Snap 2. As you can see, I have also created a new snapshot of the Swing Redo storage group. And now if I go to the details screen, you can see both of my snapshots listed. I am now going to unlink Swing Data Snap 1 from the target storage group. Note that when I do this, the ASM disk groups mounted on my Oracle hosts are unaffected. Unlinking a snapshot does not change the state of the target storage group, nor any of the linked devices. Next, I'm going to select the Swing Redo storage group, highlight the Swing Redo Snap 1 snapshot, and unlink that from its target storage group. Note that when I do this, the ASM disk groups mounted on my Oracle hosts are unaffected. Unlinking a snapshot does not change the state of the target storage group, nor any of the linked devices. As you can see, SnapData and SnapRedo are still mounted and are still available. But when I link the new snapshot, the contents of these volumes will instantly change to reflect the state of the second snapshot. So to proceed, I am now going to dismount the SnapData and SnapRedo ASM disk groups from my database hosts. When I dismount the disk group, I also like to disable it to prevent dependency errors if a node has to be rebooted later on. I just find it good practice. Now I'm going to use the ASM command afd refresh. What this does is cause ASM to drop locks on devices it is no longer using, and I'm going to repeat this on all nodes of my RAC cluster. If I now use afd lsdsk and I don't fat finger it, you can see we still have all of our relabeled ASM disks. If you watched part 1 of this video, you might recall that on the source system, these disks were labeled swing data 0 through swing data 5 and swing redo 0 through swing redo 3. Next, I am going to unlabel each of the disks on a snapshot. Why? Let me explain. When we first added this snapshot to the database host, we used the ASM relabel command to assign new labels to the disks and rename DG to rename the ASM disk group before the local ASM instance tried to mount and open the disk group. At that point, the disk labels and the disk aliases, as represented in /dev Oracle AFD disks, all matched. ASM records the disk identifier and gives it both a label and an ASM alias. If we simply relink our snapshot, even with the disk groups dismounted, the identifiers do not change. What will then happen is that ASM will have the original labels again, swing data and swing redo, but the revised ASM aliases, snapdata and snapredo. That is, the disk alias /dev Oracle AFD disks snapredo 0 will have a label of swing data 0. If you check out this output from the kfod command, you can see what I'm talking about. This is the scenario we want to avoid. All of this will still work even with the mismatched disk labels and ASM aliases. We can still rename and mount our disk groups, but we won't be able to unlabel or relabel the disks anymore. If you try to unlabel the SnapData disks, ASM will report that the disk label doesn't exist, and if you try to relabel the disk to SnapData, then ASM reports that the disk already exists. This false flag doesn't make any difference in this scenario. And you cannot unlabel a disk that has already been removed from the host, and you cannot unlabel a disk that is actively in use, even with the false flag. Note that this is only a problem if you use ASM filter drivers. If you do not use filter drivers, this whole issue goes away, so bear that in mind if you are evaluating their merits for your environment. You could also reboot the database node, and upon startup, ASM would find and assign the right labels and aliases. But some DBAs might find that approach a little unpopular with users of other databases running on the same host, so it's generally frowned upon. I'm a big fan of ASM filter drivers, but this whole disk label alias issue is a weak point in my opinion. Maybe in a future release, we will see some new options on this. With all the disks unlabeled, next I'm going to remove and drop the disk groups SnapData and SnapRedo. This helps to avoid any conflict when I remount everything in the upcoming steps. Now I am back in Unisphere, and I'm going to link the snapshot swingdata snap2 to the target storage group swingdata lnk sg001, which was previously linked to the original snapshot of swingdata. And then I'm going to link the swing redo snap2 snapshot to the other target storage group. On the database host, we don't need to rescan the SCSI bus or tell PowerPath to check its devices. They have not changed. If we issue an AFD scan now and an AFD LSDSK, you can see that we have clones of our production disks again, with the expected swing data and swing redo labels and aliases. We can now repeat the steps from part 1, relabeling the disks and renaming the disk groups. And now I'm going to show you how to terminate the snapshot, delete the target storage group, and delete the linked devices completely. As you'd expect, we start with taking our clone disk groups offline, so I'm going to dismount SnapData and SnapRedo. Next I'm going to remove the disk groups and, for good measure, force drop them too. These steps ensure that if we ever want to recreate these disk groups, we should not run into problems with leftover settings from earlier work. It also ensures that no other databases are using the disk groups, such as if another DBA had added data files to this disk group for a different database. ASM won't allow us to offline a disk group that is being used by another database. You'll note that I'm not bothering to unlabel the disks this time. That's because I'm going to delete the linked devices completely. If I ever create new ones, they'll have new WWN IDs, so will be seen as completely new devices by the ASM filter drivers. In the Unisphere interface, I will unlink the snapshots from the target storage groups, and next I will delete the masking view that allows the database host to see the devices. When we delete the masking view, Unisphere will offer us the opportunity to delete the underlying storage groups as well. Generally, this is a bad idea, as the target linked devices will remain, and unless you name them when they were created or you know their identifiers, it can be cumbersome to identify them, especially on a large system, so I usually leave this option unchecked. I repeated those steps for the Swing Redo Snap2 snapshot and its associated masking view. We now need to rescan the SCSI bus on our database hosts using the -A and -R flags to flush dead devices. We need to do this on all hosts, but you can run it concurrently. And then we need to use the AFD refresh command so that ASM acknowledges that the disks have gone. We can then tell PowerPath to check its devices. This should result in multiple paths being reported as dead, and PowerPath will then remove them. In the Unisphere interface, we can now highlight the snapshots we no longer need and terminate them. With the snapshots gone, we no longer need the target storage group, so we'll highlight that. But before we delete it, let's make a note of the volumes that are part of the storage group. In this example, they are 1 delta 0 through 1 delta 5. We can then highlight the storage group and delete it. But Unisphere does not delete the volumes. So lastly, we'll go to the volumes view, find those 5 volumes, and delete them as well. And we'll repeat these steps for the target storage group for the Swing Redo snapshot as well. And that's it. We've completely cleaned everything up. Alright, that's all we have time for today. Hope you found it helpful. If you did, maybe click like. If you found it really helpful, maybe even subscribe to the channel. And you're always welcome to come check out my frequently gruff but hopefully always helpful Oracle insights on my blog, gruffdba.wordpress.com. Stop by sometime. We'd love to see you.